Hello, young explorers. Welcome to today's enriching session of 3D questions from Steamspirations. I'm Mr. Lara, eager to navigate you through Earth's fascinating rotational dynamics and how they affect our perception of time. Today, we focus on the practical application of Earth sciences by using a sundial to understand the apparent motion of the sun across the sky. Whether you're just starting or aiming to deepen your knowledge, this session is crafted to broaden your understanding. Let's get started with a hands-on exploration using a sundial. For today's activity, we have a photo of a student-made sundial captured at 10:30 a.m. Here's your task. Observe where the shadow cast by the sundial's gnomon points. This shadow intersects a specific letter on the sundial, helping us infer the sun's position. As you analyze the sundial, consider the following. Which letter does the shadow point to at 10:30 a.m.? This will be your starting point for understanding the sun's apparent position. Given that it's 10:30 a.m., which direction, north, south, east, west, do you expect the sun to be? How does this relate to where the shadow falls on the sundial? Now let's understand more about how a sundial works with a practical example. Imagine it's early morning and the sun is just rising in the east. As the sun moves across the sky, the shadow on the sundial moves too. At sunrise, the shadow points towards the west because the sun is to the east. As the day progresses, the shadow will move clockwise around the sundial. By noon, when the sun is roughly in the southern sky in the Northern Hemisphere, the shadow points north. Then as the sun begins to set in the west, the shadow will point towards the east. This motion of the shadow throughout the day helps us tell time based on the position of the sun. Reflect on how the shadow would change if the picture were taken an hour later. How would the position of the shadow shift and why? Can you predict the movement of the shadow as the day progresses? This will help us understand the daily path of the sun due to the Earth's rotation. Based on the student's sundial, which letter is closest to the position of the sun when the picture was taken at 10:30 a.m.? A, W, B, X, C, Y, or D, Z? Select the appropriate letter and discuss why this position correlates with the sun's location in the sky at that time. Reflect on how this demonstration uses Earth's rotation to explain the cycle of day and night. So let's further engage with this concept. Discuss how the sundial's design, its gnomon, and hour markings enable us to visualize the sun's apparent trajectory across the sky. How does this simple device reveal the effects of Earth's axial spin? How does understanding this movement help us in everyday life, particularly in ancient times when electronic timekeeping was unavailable? What are the limitations of using a sundial compared to modern timekeeping methods? And how might the accuracy of a sundial vary with changes in geographic location or seasons? This discussion aims to deepen your appreciation of natural cycles and celestial movements that are essential to life on Earth. By exploring these observable phenomena, you'll enhance your ability to apply scientific principles to understand the world around you. Be sure to document your observations, insights, and responses in your Level Up workbook. This exercise not only enriches your knowledge of astronomical and geophysical phenomena, but also sets the stage for more advanced scientific explorations. Keep attending our sessions for more insights into the natural world. Let's continue to discover and learn together.